Hello everyone, in this video we're going to see example in which we're going to convert a fraction from decimal to another base. The procedure to do that is you want to multiply the decimal number by the base. It can be base 2, base 5, base 8, base 16 or whatever. So the first step is to multiply the fractions by the base. Again, this can be base 2, base 5, base 8, base 16. And you're going to get a number, and the number will have two parts, the integer part and the fraction part. And the integer is the highest order digit, and we're going to take the result of the integer and put that into the result later. So the integer is the highest order digit. And the third step is that we want to repeat the first two steps until fraction becomes 0 or we get sufficient number of product terms. So repeat the first two steps until the fractions become 0 or we get enough sufficient number of product terms. So how many number do we need to be considered as enough sufficient number of product terms? It depends on the problem, it depends on the questions, but I would recommend for binary system you go with 6 number of product terms. For base 8 probably 4, and base 16 probably 4 should be fine. And for the last step, you write the integer quotient from top to bottom to get the results. Okay, so let's take a look at the following example. In this example, we want to convert the fractions of 0.625 in base 10 to binary. So we want to convert that into binary or base 2. What you do is you take the number 0.625, you multiply with 2, use the calculator, and you're going to get 1.25. And this number has two parts. The part with the integer, which is 1 in this case. So this is the one in the fraction, which is 0.25. So from here, I'm going to get the integers is equal to 1. And the fractions is equal to 0.25. So the next step is to take the fractions and continue multiplying with 2. So 0.25 times 2, you're going to get 0.50. Again, for this number, there's two parts as well. The part with the integer, in this case, is the 0. And the fraction, which is 0.5. So the integer is equal to 0 and the fractions is equal to 0.5 or 0.50. Next, you're going to take 0.50, which is the fractions, continue multiplying with 2, and you get 1.00. And the integer is going to be 1, and the fractions is 0 in this case. Therefore, you stop the procedure and you write the integer quotients from top to bottom to get the results. So for this part, we're going to start from top to bottom to get the results. So in this case, the number 0.625 in base 10 is equivalent to 0.101 in base 2. So for this example, after doing the calculations, eventually you're going to get the fractions that is equal to 0. However, in the next example, you're going to see that the fraction is not going to get to 0 at all. Therefore, you want to continue the calculations until you get enough sufficient number of product terms. And then you can end the procedures. As I mentioned a little bit earlier, in conversions from decimal to binary, then six number of product terms should be sufficient. In base A, 4 number of sufficient should be fine, and in base 16, 4 number of product terms should be fine as well. So in the next example, the number 0.236, similar to the last example, this is from base 10 to binary. So you're going to take 0.236 multiplied with 2, you get 0.472, and you have the integer part to be 0, and the fraction part to be 0.472. Then you take 0.472 multiply with 2, you get 0.994, and the integers is 0, the fraction is 0.994. So 0.994 multiplied with 2, you get 1.888. The integer part is 1, the fraction part is 0.888. Take 0.88a, you multiply with 2, you're going to get 1.776. The integer part is 1. The fraction part is 0.776. Take 0.776, multiply with 2, you get 1.552. So the integer part is 1, the fraction part is 0.552. Take 0.552, multiply with 2, you're going to get 1.104. Therefore, this is the integer part is 1, the fraction part is 0.104. And after 6 product terms, you haven't reached fractions of 0, so you can stop the calculations here, and you conclude that the number 0.236 in base 10 is equivalent to the number 0.001111 in base 2. Again, what you did is you're going to take the integer part, going from top to bottom, and put them together to get the result like this. You want to convert the number 0.236 in base 10 to base 8. So first you're going to take 0.236 times a, use a calculator, you're going to get 1.88a, and from here you can obtain the integer part, this is to be 1, and the fraction part is going to be 0.88a. Then you take 0.88a, you continue multiplying with 8, you're going to get 7.104. The integer part is going to be 7, and the fraction part is going to be 0.104. So this is 7, this is 0.104. Take 0.104, multiply with 8, you're going to get 0.832. And the integer part is 0, the fraction part is 0.832. Take 0.832 times 8, you're going to get 6.656. The integer part is 6, which is this part, and the fraction part is 0.656. Take 0.656, multiply with 8. This is equal to 5.248. And this is 5, this is 0.248. And we haven't reached 0 for fraction yet, so we have to keep writing. And so far we have 1, 2, 3, 4, 5 different product terms. We can technically stop right here, even though I mentioned that 4 product terms should be enough. We already get to 5, and we cannot get 0 for the fraction, so you can stop the calculations right here if you want to. So thus, the number of 0.236 in base 10 is equivalent to 0 point. So we're going to collect all the integers from top to bottom, put them together, you're going to get 17065 in base 8. Now I'm going to give you another example where we're going to convert a number from base 10 to base 16. So example, I'm going to convert 0.613 from base 10 to base 16. So you do 0.613 multiplied with 16 using the calculator, you should get 9.808. So the integer part in this case is 9, and the fraction part is equal to 0.808. For 0.808 times 16, you get 12.928. The integer part is 12, and the fraction part is 0.928. Take 0.928 multiplied with 16, you get 14.848. And the integer part is 14, and the fraction part is 0.848. So 0.848 multiplied with 16, you're going to get 13.568. The integer part is 13. The fraction part is 0.568. And after full calculations, if you don't see fractions equal to 0, you can stop the calculations and get the result like that. Thus, the number 0.613 in base 10 is equivalent to. So remember, we are working with base 16. Therefore, you need to convert 12 into equivalent letter in base 16. So 12 is equivalent to C in base 16, 14 equivalent to E in base 16, and 13 is equivalent to D in base 16. Therefore, the result is 0.9CED in base 16. And that's it for this video. In this video, we'll look at different example in which we convert a fraction from decimal system to another base.